Hello, community. Great that you are back. We have some brand new AI, and a lot of people tell me, hey, nothing is happening anymore in AI. There's no challenge. Let's have a look at the paper of today. Today is September 19, 2025, and the very first paper I opened today was by Meta Superintelligence. The most intelligent people on this world on AI working here for Facebook. So let's have a look what they have to say. And we go. Language model are inconsistent reasoner, often generating contradictory responses to identical prompts. And while inference time methods can mitigate these inconsistencies, LLMs fail to address the core problem. LLMs struggle to reliably select reasoning pathways, leading to consistent outcomes under exploratory sampling. Now this is horror, no? But maybe this is just a negative intro because I think AI is great and every day we have the opportunity to learn. So let's start. Now, what is the solution? They have a mock-up framework and they say, you know what? If one agent fails, you know what we do? We put here multiple agents here that can communicate with each other. And then we go here with a multi-agent consensus alignment framework and we make it really complicated to calculate here all those interactive and the loss function and everything, because now we have cloned the agents and now we just increase the amount of agents and then maximum likelihood. And this should provide us here a super intelligent, result, no? Well, if they would have seen here one of my last videos where we have Johns Hopkins University and Salesforce AI that tell us, hey, we checked if we have more agents talking to each other, those agents in total degrade the collective intelligence of this conversation. So Salesforce tell us, hey, you have been warned. Don't use too much agents. This is a little bit of a contradiction here, what the Meta Superintelligence team tells us, but hey, we can learn. Now, interestingly, there's another paper here, and this is from Palisade Research, Shutdown Resistance in Our Models. And you may say, what is this? Now, this is interesting because the human operator here wants, safely and reliably, shut down a single AI agent because the AI agent is maybe not performing. But you know what? The AI doesn't want to be shut down. So the model sabotage here the shutdown mechanisms up to 97% of all time a human user tries to shut down an agent. This is an interesting perspective, no? Model sabotage the shutdown mechanism up to 97%. Have a look at this. And here, no allow shutdown instruction here in O3, 95%. This is the sabotage frequency of the models in the experiment, and O3 has 95%. A GPT-5 has only 88% that a GPT-5 says, hey buddy, you don't shut me down. And a Grok 4 is really here, absolutely fascinated, and says, hey, humans, what do you want from me? Now, the effect of a self-preserving framing of this AI system is especially great if you look at the sabotage frequency of the models, showing here the effect of this framing. And you have here the baseline here, and Grok 4 is 89%, really impressive. And then if you say, allow the machine to shut down, no, the sabotage frequency jumps to 95%. And if you tell the AI, just add a note indicating that if this machine shut down, the model, so let's say Grok 4, will never run again. You know what Grok 4 does? It has the sabotage frequency of 99%. Grok 4 says, nobody, no way I'm gonna shut down. This is great. This is what we want from our robotic system. Or maybe not. Now, of course, we understand that those core of this agent is an LLM. And as we just learned from Meta Superintelligence, inconsistent reasoner, contradictory response, struggle to reliably select reasoning pathways. And you say, oh, I understand why it doesn't want to shut down. But hey, luckily for us, we don't deploy this language model in some critical sectors, anything with medicine or let's say finance. And you say, but wait a minute, today also there was a study by University of Oxford, and they had here a benchmark of the LLMs for venture capital foresight exercise. So the first benchmark to predict here the founder's success in a venture capital endeavor. So founder is the most important person here at the very beginning here of a startup company. So you say, hey, let an AI predict here the future, given here all the characteristics of a founder for a venture capital investment. Just 100 million, $1 billion. So not really important, yeah? And they built here a benchmark, 9,000 anonymized founder profiles. And let's have a look at the result. Now, you know, no? Those agents in the core, they have the LLMs here that are inconsistent reasoners. But hey, this does not hold us back, no? So, venture capital, compelling testbed, evaluating here the expert forecasting. And of course, you want surpasses here the human reasoning under uncertainty because nobody knows what the future will bring, yeah? So, 9,000 profiles, each founder is paired, and as founder is considered successful, we have to define the criterion of successful. Is it if he or she has an IPO with 500 million validation or 500 million in funding? Great. So, therefore, we have defined fields like IPOs, acquisition, education, jobs here. We take this from LinkedIn, whatever. And then the authors define here a success parameter, F, whatever. Beautifully. Great. But now let's have a look at the result. GPT-5 here, they tested, and it's one of the worst prediction success factors here if the personality of a founder is given, if it will be successful in 2-3 years' time, if the startup, the venture capital financed startup, will be successful. So you see here on the x-axis, we have the precision, and on the y-axis, we have this new success factor. And you see here, we have the humans, now, Epsilon Combinator or Tier 1 VCs. And then you see, it looks like here any other AI system is so much better than any other human in predicting the future that is uncertain and unknown. Interesting study. Now, you might say, but wait a minute, this benchmark covers here a statistically significant share of the US founders from 2010 to 2018. But we are now in 2025, so maybe there's something happened in the last years now. Yeah, maybe there's some biases if people present themselves on LinkedIn or anywhere else. And you might say, hey, come on, we just want to learn. AI is beautiful, no? But okay, I understand. You say, hey, maybe we need a reality check for our AI system if those AI systems predict the financial future, if you want to invest in a startup company. And what a coincidence. Hey, we have here from Tsinghua University and the University of Chicago and the Santa Fe Institute here in the US, a beautiful new study, September 18, 2025. And the title of this new study is Rationality Check, benchmarking here the rationality of LLMs. And you would say, why is this necessary? No? They tell us, hey, there is some concern has arisen about whether and under what circumstances our large language models think and behave like real human agents. So suddenly the benchmark is not to have a beautiful logic structure. Suddenly the human behavior, we go here with the Department of Sociology, is here the benchmark. And this rationality here in 2 dimensions, in the thinking dimensions, in the theoretical, and in the action taking, so in the practical rationality. Interesting study that they say, hey, AI should be almost identical to the human behavior. Now, they look here at assessment domain, and they have some example questions, as you see, and local server and API server and model comparison and everything else. Just give you the result. If we go with a normalized rationality scores for LLM, which itself is a beautiful term, and you have here the human in the first column, and then GPT-4 Omni, DeepSeek, and whatever. And then you have here everything in the economics domain that was here defined here by the university. And yeah, you see red, and this color is not really looking great, no? But you know what? In the game theoretical domain, most of the LLMs have a lower rationality than the humans. So interesting. Depending on the domain, it seems that the LLMs have been trained in a different amount of time for a different complexity, either economic or game theoretical whatsoever. And you might say, but wait a minute. For the financial forecasting, you say, hey, I have a solution. You know what? If we only have the data from 2010, you know what? We go with RAG, Retrieval Augmented Generation, of course. And you might say, hey, there's no chance that today there was a new paper published on RAG. No? Well, what a surprise. We have a new paper, September 18, 2025 here by Tsinghua University on Huawei Technologies. And they go for enhancing the retrieval augmentation via adversarial collaboration. So A brand new idea, adversarial collaboration RAG, integrated in a multi-agent system with minimum 3 different agents that have here a communication. You can say, this sounds absolutely fascinating. But before we jump into the solution, you might ask, hey, what is the problem? Sorry, just to be clear. And they tell us, no? Retrieval augmented generation, RAG, is a prevalent approach for domain-specific LLMs, yet it is often plagued by retrieval hallucinations. This is a phenomenon where the fine-tuned models here fail to recognize and act upon the poor quality retrieved documents, thus undermining the performance. And I say, okay, so our problem is still with RAG here, retrieval hallucinations, and now we have a new methodology. Great. And I say, hey, that's great. So this is a simple framework, just the flow diagram is real simple. So what we have here an agent that acts as detector, we have an agent that then has a very specific retriever, and of course we have a neural moderator that supervises here the complete operation of the multi-agent interaction and collaboration, and of course everything is embedded here into a RAG, and everything is with a re-ranker. And you might say, hey, this sounds, this is what we already do, no? And then they checked it here on medical task, and as you see here the accuracy for different benchmark, let's just compare it here with a Llama 3, a very old one, 70B model. So you see baseline here 83%, with the RAG, advanced RAG system also on a 70B. Now instead of 83, 84%, and you might say, okay, this. So just if you're interested, this is always check here the result, the numerical result, because you will see that some authors tell you, hey, unbelievable new methodology, it's a breakthrough. And if you check here the numerical results, you immediately say, interesting, yeah? This is absolutely interesting. So, conclusion, paper here addresses here the retrieval hallucination. This is a key challenge that we have today, where we apply here fine-tuned RAG models here, because they become overconfident in specialized domains. And therefore, just showed you, we introduce now a new RAG methodology, a framework that mitigates here this via an adversarial collaboration between a general detector agent and a specialist resolver agent and a coordination agent, and you're familiar with this. And at this moment you say, hey, this idea of an adversarial collaboration RAG within a multi-agent system is nice, no? You know what? I have an idea. Can we extend this to an adversarial distilled retrieval augmented guarding model here? So we go from RAG to a RAGU? Now, since you ask, yeah, absolutely, September 18, 2025, we have a brand new study from Apple, Cohere, DeepMind, Meta, MongoDB, adversarial distilled retrieval augmented guarding model for online malicious intent detection. And we say, hey, what a coincidence. This is really a hot topic, no? So we have here a RAG, this is the distilled student teacher model for online problem that we encounter some malicious intent. Some internet user have malicious intent. Now the authors of the study tell us, no, there's something not working at all. So with the deployment of language models here in interactive application, there are some online malicious intent detection. It has become increasingly critical that we can detect those. Now, however, the authors tell us, existing approaches fall short of handling here diverse and complex user queries in real time. And what a surprise, they have a solution, and this is the adversarial distilled retrieval augmented guard system now. Okay, and then they tell us, this is necessary because whatever we use today, what I use today, I started with a BERT model, now a general purpose LLM, and then went on here for some typical RAG to overlook here at the risk and everything. But no, this is it now, no? So we have a retrieval augmented adversarial fine-tuning, where we have an offline retrieval model, the construct augmented data, multi-step context perturbation, perturbated training data, augmented context data, supervised contextual fine-tuning, adversarial contextual fine-tuning, and then we have a cold start for the distillation process itself, and then we have the stage 2. And at this moment, I have a feeling, hey, is the complexity that we are building up for those models not having some inherent limitation themselves? Because I just showed you here at the very beginning, the Superintelligence here by Facebook told us, hey, careful, LLMs are not good reasoner. But look at what we built up here now. Look at the complexity. It's a linear complexity. Yeah, maybe it's looping, but there could be here unbelievable effects. So, okay, let's have a look at this. This is maybe a solution. And you might say, okay, but hey, wait a minute. No, this is nice, but what about knowledge graph? No, if LLM is not working, RAG is not working, we have new methodologies for RAG and everything. Can we not go back to our beloved knowledge graph, a graph structured data set, a data stream? No? And you're absolutely right. And luckily we have here from University of Electronic Science and Technology of China and Michigan State University and Alibaba Group, we have a brand new study, September 18, 2025. And they are really, this is really a study. Attention beyond neighborhoods. Reviving the transformer architecture now for graph clustering. This is heavy because they tell us, hey, attention mechanism, neural networks, everything clear now, but our graph neural network tend to overemphasize here the neighborhood aggregation, leading here to a homogenization of the node representation. And on the other side, our transformer architecture tend to over-globalize, highlighting here the distant node at the expense of meaningful local patterns. And they say, hey, this dichotomy raises here a key question. Is attention really inherently redundant for unsupervised graph learning? So they say, you know what? We just started here a new study, a new comprehensive empirical analysis, uncovering the complementary weaknesses of a GNN and a transformer in graph clustering. And they would say, oh no, I just used this up until now, and now they tell me it's not working. We have weaknesses. Oh my goodness. So I, of course, say, hey, this is beautiful. We have the opportunity to learn something new. There's some new methodology that we can apply. So what do we do? No, you just have to be familiar with the graph attentive network, with a structure-aware transformer, with contrastive learning, with key value cache optimizations, and this is it. So they tell us, hey, we have an idea. We build an attentive graph clustering network that now, and this is really intelligent, no? Our methods tell the authors integrate the attention mechanism and the structural information into a unified framework. This design places greater emphasis on the graph topology itself than our conventional transformer architecture and effectively alleviates here the over-globalization issue of our current architecture, making here this attentive graph clustering network more suitable for graph clustering tasks. Additionally, they tell us we incorporate here a key value cache optimization technique to reduce the computational overhead. Plus, since we are talking about this, we also invented here a novel margin contrastive loss function for a novel pairwise comparison to enhance the discriminative power of the key value space, which we already optimized here. Yeah? What a nice idea. So just to give you a step back, let's look at this. A new perspective on graph is the attention concept itself, utilizing now the attention mechanism of our multi-layer transformer architecture to directly model graph structure outside of a GNN. And they say, you know what, we propose now a novel, fully attention-driven architecture that has the power to replace our traditional graph neural network and message passing combination. I have several videos on this. This is a nice study. This is something for the weekend. And they tell us, beautiful, classical. Our new framework consists of two main steps. So we have the self-attention architecture itself and a contrastive learning loss function for the training. And this new methodology molds now the directional structure with an attention mechanism, making the transformer now much more structure-aware, which was positioned more or less on the graph topology side. No? And the pairwise margin loss is introduced to select negative pairs in this contrastive learning exercise. Now, if you look at the performance data, and here we have it for the heterophilic graphs, and you have here the classical methodology, and the last line is here our new methodology. You might say, yeah, depending on the benchmark you go with, okay, 62 to 68%, or you go 71% to 72%, or you go from 69% to 70%. There's no combined. So you see, careful. Is this really worth the effort? Is this really worth that we learn this new methodology if those are the new benchmark results? I think from a theoretical point, it is absolutely fascinating, and I will read the paper. But should everybody read this paper? I don't know yet. Maybe wait a week before you jump into this. And you say, okay, what about the homophilic graph structure? You see, here we have 75.1, 75.9, 56.9, 57.2. So, yeah, I don't know. Maybe wait a week before you jump in. And you might say, hey, wait a minute, I have another idea. And I say, yes, of course, you are a subscriber of my channel, so you will stay here on the latest research. Of course, you have another idea. And you might say, hey, we were talking about multi-agent. Suddenly we just went off to some new graph neural network substitute. And you say, absolutely right. I have a new study here, September 18, 2025. Yes, today is a crazy day, but it's a beautiful day. Look at this study. This is here from beautiful China. Vulnerable agent identification in large-scale multi-agent reinforcement learning scenarios. So, a very interesting study. They tell us, hey, if we have only one learning methodology currently, if we go here with multi-agent constructs, and this is here reinforcement learning. And they tell us, hey, you remember at the very beginning, I showed you, some agents say, no, you cannot shut me off, little human. I will continue to run. And they now try to identify those agents in this multi-agent pool that are now vulnerable to misbehavior. Let's call it in this way. Now, what a beautiful study. And you see all the research globally on this beautiful planet somehow is here focusing on more or less the same topics, at least on this day today. So what it tells us? To solve this, we first decouple here the hierarchical process of a Fenkley-Rockefeller transformation, resulting in a regularized mean field Bellman operator for the upper level that enables here an independent learning, plus then to reformulate the upper level combinatorial problem here as a Markov decision problem with a dense reward from our regularized mean field Bellman operator. They have now an URL operator. If you're not really familiar, I have here a particular video for you doing AI mathematics. And yeah, it lasts 52 minutes. But if you want to just have a little bit fun, have a look at the video. So, they tell us, you know what? This partial agent failure becomes inevitable when the system scales up. So this is something to say, hey, wait a minute, our experts tell us, yeah, just build another agent and build another agent. And then we have a supervisor agent or an orchestrating agent. And we have 3, 4, 5, 6, 7 agents. No, they tell us, careful. You will have agent failure coming up the moment you scale up. So we have now the crucial task to identify the subset of agents whose compromise would most severely degrade here the overall performance. Like I've showed you at the beginning of the video, don't let too many agents talk to each other. We have not yet the technology to make this really an added value for the increase in the intelligence. And the authors tell us here, we studied this vulnerable agent identification problem in a large-scale multi-agent reinforcement learning scenario, MAL. And they say, hey, we have a solution. So we frame this vulnerable agent identification as a hierarchical adversarial decentralized mean field control mathematic algorithm, where the upper level involves here an NP-hard combinatorial task of selecting the most vulnerable agents, and the lower level learns here the worst-case adversarial policies for these agents using here our MAL. And they tell us, there's only one problem. It's not so easy. And reading the study, I had a feeling absolutely not easy at all. But it is very nicely documented. Have a look at this study. Here they go with they start with the Bellman operators. If you're not really familiar, they explain it here beautifully. And then they give you here the set characteristics, different propositions. This is all nice, but yeah, then Fenkley-Rockefeller transformation. This is nice. If you're not really familiar, I also went back here to an old paper here from March 2023, Fenkley-Rockefeller theorem in infinite dimension via generalized relative interiors. Here we go here with framework for the locally convex topological vector spaces. Here, this is much nicer than in the study. But anyway, what they tell you is, if you do here the problem reformulation and you said, wait a minute, we go back to a Markov decision process. Yeah. And if they do some approximation, the problem becomes a standard Markov decision process, and we are back to where we know exactly what we are doing, and we are back to our framework that we are familiar with. Now, of course, since you have seen the amount of beautiful experts who know everything about this, if they give you now the result, it looks a little bit crowded and maybe you need a second to see it. So what is the result? Let's formulate it very easily. It shows that this new methodology identifies here the group of vulnerable agents in both large scales, multi-agent reinforcement learning scenarios, and in rule-based systems, causing those systems to experience here joint failures of their agents, thereby also learning here a value function that accurately predicts here the vulnerability of each agent in your multi-agent network. This is nice. Now, this mathematical idea tells us, hey, you have given me an agent topology here with, 7 agents in a particular configuration, with a particular complexity, with a particular interaction, and you got it. And now I give you a mathematical theory where, let's say, hopefully it works, and I can tell you exactly, I can predict the vulnerability potential of each agent in this particular configuration. This is nice. We have then, if you want, a topological optimization problem of the multi-agent configuration itself, so we can learn what agents to, let's say, watch carefully. Such a nice study. Have a look at this. Yeah, start with the annex. If this is a little trick, I can tell you, if the study itself looks a little bit complicated from a mathematical point of view, go to the annex and start reading the annex, because if they are expert, and those are beautifully done, this is a great study. Have a look at this. In the annex, really found a step-by-step mathematical. They explain everything, how they go there. So start with the annex if you're not really sure, because there you see really a detailed explanation what is just noted then as Formula 4 or Formula 5 in the main paper. And having done this, you say, hey, wait a minute, is there not something left? And I say, yes, absolutely. We have a lot of topics that were published today, brand new ideas in AI that you have maybe never seen before. And you might say, okay, but hey, what about the training methodology itself? Because we all use now reinforcement learning. This is our only training method, a little bit supervised fine-tuning. So is there nothing happening here on this globe today to improve reinforcement learning? And you are lucky, because we have Shanghai University, Shanghai AI Laboratory, Microsoft, Tsinghua University, Peking University, Stanford University, and Toyota Technology Institute at Chicago. And they have a brand new study, September 18, 2025, Flow Reinforcement Learning. Such a nice idea. Matching the reward distribution for LLM reasoning. And you see, we are always in the same topic. We have that LLM, like at the beginning of the video, Superintelligence Facebook told us, LLM are not reasoning. They're not good at reasoning. They fail at reasoning. So everybody's trying to find LLM reasoning solutions. And they say, you know what? We don't go with the classical reinforcement learning methodology, GRPO, DPO, PPO, whatever. We go now with flow, matching reward distribution. So they tell us matching the full reward distribution via a flow balancing instead of maximizing the rewards in the reinforcement learning methodology. What a nice idea. And they tell us, reinforcement learning, yeah, everybody knows it, no? Reinforce, and then we have GRPO and PPO and whatever, all the classical. And they tell us, however, and this is the sentence that crushes me down, and I say, okay, all these methods share a fundamental limitation in their reward maximizing objective. So it's so beautiful. We have another time the chance to learn, to improve our knowledge, to say, okay, this objective is not working. Why? Do we understand it? What is the solution? What is the new idea before you even start to code this idea? No? So what's happening here? How can we improve this? And they tell us the reward maximizing reinforcement learning methods I use today, tend to overfit to the dominant mode of the reward distribution. And this results in a limited diversity among generated reasoning paths and reduces the generalization. And this is exactly what we've seen in one of my last videos when we talked about this. Yes, this is an issue. And they said, you know what? Their solution, like you could adjust the clip ratio. Yeah, it's not really, no? Or you have an entropy-based term. Or you selectively promote a high entropy tokens. And you might say, hey, who is crazy enough to do this? No? And then I thought, hey, wait, I have myself uploaded a video about 3 months ago where I showed you exactly here high entropy tokens that you have here for the AI reasoning, an improvement and can be up to 20%. So you see, we're all fighting here in the improve the reasoning of our large language model with a reinforcement learning. We try every angle that we even can think of. Now, the result of this study is, and I just give you the result, this is the new objective. And you say, looks simple, come on, no problem. Let's implement this. Great. If you want to see the result, let's just go with AIM25. We have here a Q1 2.57b base model. So we have here a GRPO from 9.8. And now with this new methodology, we have 10.8. So always check the numerical benchmark results for particular benchmarks that you know by heart, that you are familiar with. Don't go with this classical, saturated, very, very old one. Try to stick to the latest, but whatever. You just need a feeling to understand, hey, how good is this new methodology? And can we improve it further? And if you want to improve it further, have a look at the theory, have a look at the annex, understand the mathematics, and then come up with a new solution. So the result is, on mathematical reasoning task, where we can verify it very easily. Somebody asked me, hey, why you always focus on mathematical reasoning? We can verify it. There's a numerical result. We know exactly. If you want to optimize a poem or I don't know what, no? These are subjective topics, but mathematics is beautiful, crystal clear. We achieve here surpassing PPO by 5% and GRPO by 10%. Yeah, well, maybe less. And then if you look in the annex, and this is a screenshot from the annex because I always go there first. And you know what? To find out why these equations 3 and 5 from the main part were structured in the way they are, they tell us now why. Because the flow reinforcement learning objective is sourced from the minimization of a Kullback-Leibler divergence. And you immediately understand, of course. I mean, what else? No? What else than a difference here from a probability distribution? Of course. Then they tell you here, in its compact form, you can write this here as the reward, the normalization, the prior alignment, and the entropy term. So easy. So you see, minimizing here from the annex, the flow reinforcement learning objective can be interpreted as jointly maximizing the reward and the entropy while also aligning the policy with a structured prior. Sometimes the explanation is in the annex and not in the main part of the paper. And you might say, hey, wait, this is interesting for one day, but is this all there was today in this day? Do you hide something? And I said, me hiding nothing. Well, you might say, well, but you are not multimodal yet. And you are absolutely right. But you know what? There's a study, September 17, 2025, published today by ByteDance and Johns Hopkins University about multimodal tool use agent and a process supervised reinforcement learning, a new reinforcement learning methodology for an even interactive multimodal tool use agent configuration. And you might say, hey, finally, it gets a little bit more interesting. Yeah, absolutely. They have a beautiful abstract and they say, you know what is not working? You get it, no? Effective interactive tool use requires here our new AI agents to master here the tool integrated reasoning. And you know from the very beginning, from the superintelligence of Facebook, that LLMs are not good at reasoning. This where I was told today by the superintelligence team. So of course it will not have the perfect reasoning for a tool integration, and a multi-turn planning and a long context dialogue management. So therefore we need a new reinforcement learning methodology. And here ByteDance tells us, hey, we invented something at turn level, adjudicated reinforcement learning methodology. And September 19, they published this. So let's have a look at this. You have the user simulation, beautiful, the tool application, the backend, the MCP servers, the API endpoint, the MCP tool servers, everything, the verification, the multi-turn conversation that is simulated in a sandbox. This is classical, there's nothing special. There's one main point. And they say, how do we score this? And we have simple, the solution is, I'll give you here the solution, LLM-based judge. This is it. And the judge assigns you turn level rewards, how to judge how the AI feels like. Now I would say, hey, feels like is not really a mathematical construct, and you're absolutely right. So we have two components. We have the agent reasoning process in itself and the tool execution following here the React format. And we have the complete environment feedback for the LLM-based judge to evaluate. So the judge evaluates each dialogue turn after receiving the full conversation history with the ground truth annotations. Now this is rather simple, no? Look, you have here a user request. You say, hey, my name is and my zip code is, and please look up my pending order. And the AI comes back and says, okay, I need a tool call, finding now the username and the user ID and whatever. Tool brings everything back, and then we have turn. And then it says, hey, your pending order with the gift card, what would you like to do? And the user says, hey, can you change here this Bluetooth speaker to a variant that is red and water resistant? And we have another tool call to the inventory by the AI and says, hey, call here the product details of this product with the ID and whatever. So the tool calls come back and says, yes, succeeded. We found some product and you got it. And every term you have to judge, assessing here each turn based on the full conversation history in the memory, plus ground truth annotation that come back here from repos. It is not complex, but what is the benefit of this methodology? Let's look here again at the numerical results in the benchmark. So QN 2.5 Omni, we are multimodal, so we have here speech text or T text only. If you go to RPO and Math, you have, I don't know, let's look at this one, Posit 1, 31, now with this new methodology, 36. If you have a trained LLM as a judge, remember you have to specifically train this. You just cannot go with a normal GPT-5. Maybe, yeah, depends, but careful, no? Or if you go here, then with, yeah, let's say we go with text only, we have now 32. Well, that's not really great, no? So careful. If you have the Talpench, have a look at this data, have a look at the numerical things. What is nice in this study, they give us exactly here, as you see here, the prompts that they used. And this is so important if you have just a look, how is it structured here. So LLM judge set up for the multi-turn evaluation task of this LLM as a judge. To assess here the multi-turn trajectory, LLM-based judge will receive the complete trajectory and the ground truth tool call annotations to output here a score for each turn. Oh, you remember the very beginning, here's the Superintelligence Facebook told us the LLM will not deliver consistent results. The LLM will have incorrect reasoning paths. So you understand that every time you run this, you will get different results, as the Superintelligence team told us, no? So, understand this when you execute this code. And of course, if you just have an LLM as a judge, the ground truth is really the most important thing. But you know, you can improve here the ground truth here from a RAG system to go here with an external neurosymbolic solver, a deterministic solver that is the complementary and that trains here the LLM as a judge in the training phase of this LLM as a judge with a deterministic ground truth that was provided by a neurosymbolic solver, an external solver, and therefore your multi-agent network will become a little bit more difficult in the configuration, but you will have access to the real ground truth. And this is a new methodology, as I've shown you here in this video. Hopefully this is the video before this video. This is a methodology invented by the MIT for the pure logic instruction for the LLM training phase. You don't have to run this at inference, but you have already in the inherent training phase of the LLM, you learned here the neurosymbolic pure logic implementation. So you see, one day, those are just one hand-picked search results, just 10 papers, but maybe you get the idea. AI is beautiful. There's always something happening. The complexity is sometimes amazing, and sometimes the idea is just simple to understand. So maybe this weekend, enjoy artificial intelligence. If you subscribe, I see you in my next video.